and we have discussed about what is this regular event control, what is this at the rate passage of clock, negate of clock, and we also declared about implicit in the arguments, and we have discussed about named event controls and event hour control and level sensitive trigger control. So these are all we have discussed up to previous sessions. So in this session we will start with the another topic called conditional operators or conditional statements. So our topic is conditional statements. So conditional statements are nothing but like if loop, if else loop, like that. So in conditional statements, we will first discuss about if else loop. This is a simple if else loop. So basically, if else loop is nothing but, for example, if condition 1 is true, then the following statements will be executed, else another set of statements will be executed. So this is the basic working of an if else loop. So if condition 1 which is specified in the if loop is true, then it will get executed, or else the statement which is written inside the else loop will be executed. So this is an if else loop. So we can also write if condition is true, then the statements which are written inside the if loop will be executed, and if we not mention any else condition here, then simply the if loop will be executed, and if the condition is false, then it will come out of the block. It will not execute the else since we have not mentioned any else. So this is the basic if else loop, or else we can have if and else if nested, or else it is also called as nested if. So if statement, sorry, if condition 1 is true, then the statement 1 will be executed, then the statement 1 will be executed, else if condition 2 is true, then statement 2 will be executed, else if we can also write any other condition if it is there, condition 3, then statement 3 will be executed. So this is nested if else statement. So if condition 1 is true, then the statement 1 will be executed, else if condition 2 is true, then the statement 2 will be executed, and if condition else if the condition 3 is true, then the statement 3 will be executed. So there are three types of if loops. First one is if without any else, and second one is if else, and third one is if and else if. So these are the conditional statements in behavioral modeling. Is it clear?
Yes.
Next, we will start with another conditional statements which is called. Now we have another conditional statement called multi-way branching. So in this we have two types. One is case statement and another is case X statement. So we have two statements. One is case statement and another is case X statement. So we will discuss one by one. So in case statement, so we have a, the syntax for this case is case followed by expression, and if it is expression is matching with this alternative one, then statement 1 will be executed, and if it is matching with alternative 2, then statement 2 will be executed, and if it is matching with alternative 3, then the statement 3 will be executed. So like this it will work. And we should also mention one default statement, default underscore statement. So we should also mention one default statement. That is, if any of the alternative is not matching with the expression, then our default should be executed. For example, if we have a register, say A, and if we take case A, then if A is equal to 0, then statement 1 should execute it, and if A is equal to 1, then another statement should be executed. So according to the value which the A is taking, we are mentioning the possible cases. When A is equal to 0, the first possible case should execute, and when A is equal to 1, then the second possible case should be executed. And if, for say, suppose we have reg 2 down to 0 A, that is A is of 3-bit register, then if we write case A, then there will be 2 power 3, that is 8 cases possible. So 3 tick binary 0 0 0, then we can execute some statement, and if it is 3 tick binary 0 0 1, then some statement should be executed. Like that we can go up to 0 0 0 to 1 1 1. So this many possible cases are possible with reg 3 down to 0 A. Is it clear? So this is how we can use a case statement. Is it clear? So in this case, if we take case A, and if we have 2-tick binary, sorry, it is a 3-bit variable. So if we take 3-tick binary 0 0 1 x, and if we take another as 3-tick binary 1 1 x, then if A is here, in case of unknown, here the case statement cannot compare the unknown values, so it will take the default value specified. So the statement which is written inside this default case will be executed. This statement only will be executed, because in normal case operation the case cannot compare this variable with the unknown values, so we will get an default statement. So in these cases this will not work if there is an unknown value. So this is our case statement syntax and the working of the case statement. Now let us see the working of case X. So in case of case X, we will have so if we take case X, and if we have, say again A, and if we take 3-tick binary 0 x x, and if we have 3-tick binary 1 0 x, then if A takes the value of 3-tick binary 0 x x, then if we use this case X, then this case X can compare A with this case possible cases. Here A is taking the value of 0 xx, and we have a case of 0 xx, so the statement which is written inside this case will be executed. So we will get our output. So basically this case X statement is used to compare the unknown values also. Compare the unknown values also. So using this case X, we can compare the unknown values also, whereas in normal case we cannot compare the unknown values. So this is the difference between the normal case and case X. Is it clear? Is my voice clear, right?
Yeah.
So this is the difference between the case and case X. Now coming to the next topic, which is loops. So in the loops we have while loop, and we also have for loop. So we will start discussing about while loop now. So these are similar to the one which are present in our C language. So these are similar with that. So in case of while loop, the syntax for while loop is while the condition is true. So inside the while, so the condition, if the condition is true, then the statements written inside the while loop will be executed, or else, so we should write a begin and end in this while loop. So if the condition specified in the while loop is true, then only the loop will get executed, or else the loop will not at all get executed. For example, if we are writing while a is greater than 1, then begin, say b is equal to 3, and ending this. So in the test bench or somewhere, if we make this register a greater than 1 only, the while loop will get executed. So whenever a is greater than 1 only, then the value of b will be equal to 3, or else if it is not equal, or else it is not greater than 1, then the value of b is equal to 3 will not be assigned, or else we can write b is equal to b plus 4. So anything we can write this statement inside the while loop. So if the condition specified inside the while loop is true, then only the statements which are written inside the while loop will get executed. So this is the syntax and usage of while loop. Is it clear? So we will use all these loops and conditional statements in behavioral modeling while coding, say suppose like SR flip-flops or else D flip-flops or some counters. So while coding all this, we will use these loops, all these things. So if you are having any doubt, you can ask me. Next, coming to for loop, the syntax for loop is for variable is equal to 0, variable less than some given condition, we can increment the variable or we can decrement the variable. So here basically we are first initializing the variable and we are mentioning some condition, whether it can be less than the condition or it can be greater than the condition, and we can increment the variable or decrement the variable. For example, we use for I is equal to 0, I less than or I less than 5. In this example I am taking I less than 5, I plus plus count is equal to count plus 1. We can use begin. So here what's happening, I should declare I as an int I. So first I should make I to equal to 0 and I less than 5 and I plus plus. So this is basically an iteration loop. So it is an iteration loop. So basically in first iteration what will have, I is equal to 0 and count will be equal to 0, sorry, count will be equal to 1, and in second iteration our I will be equal to 1 and count will be equal to 1 plus 1, that is 2, and in third iteration I is equal to 2, I is equal to 3, 4, 5, so on, and count is equal to 3, 4, 5. Sorry, here I will be up to 4 only and count will be equal to 5. So after reaching the value, that is I is equal to 4, which is less than 5, the simulator will get out from this for loop. So until we reach the specific value specified here, our loop will get keep on iterating. So this is the user, this is a syntax and usage of for loop. Is it clear? So this is one of the iteration loop, and we have one more loop which is also iterating, which is called repeat loop. Basically, this for loop and repeat loop will be mostly used in the test benches. So we'll see how we are using them in the test bench also. So in case of repeat loop, the syntax is repeat, and we can give some hardcode number like this, like repeat of 5, like this we can give. So what happens, we are mentioning repeat 5. So the statements which are written inside this repeat loop will be executed 5 times. So after completing this loop, the simulator will get out of this repeat loop and it will end. So we should again use begin and the statement should be inside should be written inside this repeat loop. So we have mentioned 5, so this repeat loop will run for 5 times. If we have not mentioned any hardcode number, like we have only used repeat, clock is equal to not of clock, so this will keep on implementing for infinite times. If we are not mentioning any value, it will keep on implementing for infinite times. So this is the syntax and usage of repeat loop. Is it clear? And we have one more loop which is called forever loop. So basically this loop will executing forever. So as the name suggests, this loop will be executing forever. So this is also basically used in our test benches, not in design. So this is basically for simulation purpose. So for example, the example for this is forever clock is equal to not of clock. For generating a clock, we can use forever clock is equal to not of clock. So this will be executing forever. So these are the some of the conditional statements and loops in behavioral modeling in Verilog. So is this clear for everyone? Is it clear?
Yeah, clear.
Yeah. Now let's discuss one more topic, which is sequential blocks and parallel blocks. So we will discuss this. So we have already discussed about the sequential blocks. Sequential blocks. So coming to the sequential blocks, our initial beginning, so the statements which are written inside this initial block are sequential statements. We have already discussed this in our previous sessions. So within an initial beginning block, say suppose A is equal to hash 10 0 and B is equal to hash 5 11 and C is equal to hash 2 1. So the statements which are written inside this initial beginning block will be executed sequentially. That is, one after another, these statements will be executed sequentially. So after completing A is equal to 0, then only B will be equal to 11, and then after C will be equal to 1. So that so like this, the statements will be executed sequentially. That is one after another. So this is sequential blocks. We have another type of block which is fork join block or else parallel blocks. So we have one more thing which is called parallel blocks. So the syntax, so for using this parallel blocks, we can use this fork join. So basically when we write this fork join, then the statements which are written inside this fork join will execute parallelly, not sequentially, parallelly. So the statements which are written inside this fork join will execute parallelly. For example, if I write initial begin, sorry, initial fork. Say suppose m is equal to 1 tick binary 0 and hash 2, n is equal to 1 tick binary 1, and I'll write here join. So I'm writing the statements inside this fork join, and I should use initial. So m is equal to 1 tick binary 0 and n is equal to 1 tick binary 1. So here what happens, the value, I will write one more statement here. Say suppose hash 10 p is equal to 1 tick binary 0. So at 0 time units only, I will get the value of m is equal to 0, and at 2 time units, I will get the value of n is equal to 1, and at 10 time units, I will get the value of p is equal to 0. This is executing, this is getting executing parallelly. So if I don't use fork join here, then I will get at 0 time units the value of m, and at 2 time units, I will get the value of n, and after 2 plus 10, that is 12 time unit, I will get the value of 0. This is executing sequentially. So if I use the fork join, then at 0 time units only I will get the value of m, and at 2 time units I will get the value of n, and at here we can see at 10 time units we will get the value of p. So this is the difference between the fork join block and normal block. We are getting the values parallelly. So all the values, all the statements are getting executed parallelly. The delay is because we have mentioned the delays here. So is it clear the difference between the parallel and sequential blocks? Are there any doubts? Is it clear?
Yes.